My name is Hannah Marr, and this is Blaster Master for second CA for multiplayer games programming. I worked on this project with Andrew Disley, and I'm just going to take you through the major changes that we've implemented since the last iteration of this game. So one of the first things we did was we fixed an error in which the damage to the player wasn't being calculated. We have two different bullet types, which I will get more into in a second. But in the previous iteration of the game, no matter which bullet type you used, the players took no damage. We're not entirely sure why this happened, other than when we went through this if statement here, originally it was just M health minus damage amount. And there wasn't any need for a loop or anything like that, or so we thought. That method didn't work as intended, and so what we've done instead is we've changed the way the damage has been taken back to M health minus minus, which means it just gets deducted by 1. But we've implemented a for loop which goes through each damage amount. So if it's a normal bullet type, it'll go through the loop once, thus minusing 1 health from the player. And if it's a super bullet, which I'll go into in a minute, then it goes through the loop 5 times and the player loses 5 health. One of the other things we did, because of the fact that you lose up to 5 HP now with the damage, we've increased the amount of health that a player can have. So we've implemented it so that the output stream for the health can go up to 5 bits, which gives it a max value of 32 available. But then in mouse server, for our mouse, I am in the wrong file. That explains why I can't find what I'm looking for. Here we go. Yes. So originally in the previous iteration, because of the bit count for the right for the health was only 4, the health wouldn't go beyond 14, no matter how many pickups the player picked up. We've now changed that, obviously, so there is a max of 32, but we decided to cap it at 20 because that's double the initial health that you get. Another thing that we did was we created our own collision objects, which act as barriers to the player. Bullets can still pass through, but the players cannot. And creating the new class involved creating the general class in General RoboCat, which is just collision object CPP and .h. We also have the client side, which is just the setting of the texture, and then we have the server side. It's a fairly simple collision object. All it does is return true when it handles the collision with the cat, meaning that the cat can't with the cat or the player, which means that the RoboCat treats it as a player on player collision or cat on cat collision, and they cannot pass through the object. And I'll showcase that in a little bit when I run the demo. Another thing that Andrew did was create the super yarn class. And in a similar way to the collision object, we had to make the generic version super yarn, then we made the client side, and then we made the server side. And super yarn is 100% Andrew's creation. It's basically a more in-depth version of our secondary bullet type, whereas previously it looked and acted like a regular bullet. It just did more damage. Now it is scaled up in comparison to the regular bullets. Again, you'll see that during the demo. And it also, as I said, has its own server and client side states that can be edited. We also now have text inputs for the IP and the port and player details. So if I just go into RoboCat client, you see here we have client details, in which we put in the player name, the IP address and the port number, and then over in server we have the server port .text, which has to match. These are read in client CPP and server CPP respectively. As you can see here, if stream in file, client details, and then it gets each line for the destination and for the name, rather than reading it in from the arguments. We also have some improved persistence, as you might have seen a second ago when I was looking at the mouse server. Yeah, so we have it now. We still have the original persistence, in which when a player enters the game, it writes to the file saying player name has been welcomed as player ID. So Hannah has been welcomed as player 1. What this method does in the mouse server is it says when a player has picked up health. So it adds more of a game log to the persistence file that I'll go into after the demo. So yeah, you can see here, player ID picked up health, and it's also it also occurs when the player gets a kill or achieves a point. So yeah, here in the RoboCat server, it appends the kill to the text file, and it should be noted that depending on which lines are written, there's also slight indentations, and also these are only being appended to the document, so it does not rewrite the whole thing. Before I move on to the demo, I'm going to talk a little bit about the network. So the network uses UDP protocols, and all in all isn't too dissimilar from the original RoboCat code. The biggest changes we made to the network was the creation of the collision objects and the super yarn, because that involved dealing with both the client side and the server side, and making sure we didn't change anything too drastically there. But all in all, the network isn't too dissimilar to that of the original RoboCat code. Okay, so now I'm going to run the server and just one client, because I don't know if you saw my last screencast for this, then you'll know that running 2 clients or more causes the capture to get a bit weird. So we're just going to start off with 1 client, and then I'll just spawn in a second one for the purposes of showing all the persistence. Taking a while for the server to start, always a good sign. Allow access. Okay, server is running. I'll get up the first client. Hopefully this runs okay. Well, I have an interesting round trip time, but that's my. Oh, you might see that up here my health is 12 rather than 10. That's because I spawned on a pickup, which is a happy little accident that sometimes happens. So these little blue boxes are the pickups, which give you health, and these red boxes are the walls. So to simulate what I was talking about earlier in terms of the player-on-player collision, if I walk into this box, I can't. I get bounced around, which makes it a little difficult when maneuvering, but that's kind of the point. So another thing, just go around and see that you can collect the pickups. Great. So I picked up a pickup, and I'll just pick up another one for good measure, and that should now be added to the persistence as well. So as I mentioned earlier, we have our 2 different bullet types, yarn and super yarn. So that is our super yarn, which is used by pressing L, and this is our regular yarn. As you can see, super yarn is double the size of the regular yarn, and it also travels much slower, but also has a greater distance. So just to make sure that to show off the persistence, I'm going to attempt to run another client. This may make the capture go weird if it hasn't gone weird already. And what I'm gonna do is I am going to kill this other player, and they've disappeared, they've respawned, and you can see that I've gotten the kill, and they've respawned down here. So I'm just gonna close all this down. Not gonna open the Windows store. That's not what I want to do at all. And then we're gonna go into assets and have a look at session.txt. So you can see here, new play session, player 1 was welcomed. You can see all the times that player 1 picked up the health pickups, and you can see player 1 was welcomed on client as player 2, because I didn't bother changing the name in the input. And you can also see player 2 got a kill, and you can see the various points of indentation here. Alright, I believe that is everything. My name is Hannah Marr. I worked on this game, Blast and Master, with Andrew Disley, and thank you for watching my screencast. Apologies for any dips in quality in terms of the recording.